Hello everyone, in today's video we want to be looking at the single covalent bonding. But before then, let's briefly explain the structure and bonding. The structure and bonding, this simply refers to the arrangement of atoms and forces that holds them together in molecules and compound. In today's video, we are going to be focusing on covalent bonding, and under covalent bonding, we are strictly going to look at the single covalent bonding. So, what is single covalent bonding? Single covalent bonding, this is simply the type of chemical bond formed when two atoms share a pair of electrons. Let's take an example. Let's say we are given atom A and we are given atom B. And in this case, let's say this is atom A and this is atom B. Let's take an example. Let's say this is non-metal and this can also be non-metal. It can also be metalloid. Let's say this is A and this is B. Let's say here we have positive and here they are unpaired. And the numbers of valence electrons, let's say here we have 6. This is going to be 2 multiplied by 3, that is 6. 2 multiplied by 3, that's 6. Let's say we have plus 1 here. And here we also have, this is making it 7. And here we have 2 multiplied by 3. This is also going to be 6 plus 1, that is 7. So, here, if you join these two together, this is simply going to be we have the atom A and we still have our atom B. In this case, they can either join together in this form or separately. Let's try it separately and try to show the numbers of valence electrons in this case. Let's say we still have our valence electrons, we still have 1 here. Since we said valence electrons are the electrons in the atomous shell or energy level of an atom. And in this case, we have 7, 7. This is 2 multiplied by 2, that is 4. 4 plus 2, that is 6. 6 plus 1, that is 7. 7 multiplied by 2, that is 14. So in this case, if they share these 2 electrons, so yeah, 1 electron, that is if they share one pair of, here they share one pair of valence electron, and still here we can have our atom A and our atom B. So this is simply the covalent bond, a covalent molecule, which we can say these are single bond. Let's take an example with HCl, which is hydrochloric acid. HCl. In this case, here we have 1 hydrogen with 1 valence electrons. Chlorine. And this will give rise to some hydrogen with 1 covalent bond. So, in this case, in the case of hydrochloric acid, it has 1 hydrogen atom with 1 valence electrons and 1 chlorine atom with 7 valence electrons. In this case, a single bond is formed between hydrogen and chlorine by sharing 1 electron. So you can choose to do it differently by putting it, since we have one hydrogen, here we can have the one hydrogen, and here we can have the chlorine. In this case, chlorine is going to have 3 differential. This is 1, 2, and this is the third one. In the case of hydrogen, it's simply going to have just one shell. So here we're going to have 2 electrons. The next shell we're going to have 6 electrons. 2 multiplied by 2, 8 electrons. 2 multiplied by 2, that is 4, plus 2, 6, plus 2 is simply 8. The valence electrons is going to be 7. This is going to be 2 multiplied by the opposite 2, that is 4, plus 2, 6, and we're going to be left with 1. In this case, chlorine has 7 valence electrons. In the case of hydrogen, it's only 1. It only has 1 valence electrons. So we can simply connect these two. What about hydrogen? Let's say we're given hydrogen, which is H2. And this is the later. And we said the numbers of atomic shell here is just going to be 1, 1, 1. Numbers of valence electrons is 1 ratio 1. I mean 1 here, 1 here. What about ammonia? In this case, ammonia is simply NH3. We have 1 nitrogen saturated with 3 hydrogen. Let's try to see how the structure is going to be, since we are dealing with just single covalent bonding. This is going to be nitrogen saturated with 3 hydrogen. Let's put it this way: 1 hydrogen, remaining 2. We have 1 here, and let's have another 1 here. But in this case, we're just going to be focusing on the valence electrons, which is the numbers of electrons in the outermost shell. Let's say we have 1, and we have 1 here, and we have 1. In the case of the nitrogen, we're also going to have 1. So, numbers of valence electrons in hydrogen is simply 1. The other hydrogen is also 1, and this is also 1. Valence electrons in nitrogen is going to be 5. Here we're going to have 1 here, 1 here, 2 here, and at the right hand side we're going to have 1. So what we are left here with is for us to connect it. Here, the top hydrogen is going to connect with the bottom hydrogen at the top is going to connect with the nitrogen. At this side here, it's going to connect, and here we have the last one. So let's take an example. I think this is it for this problem. In our next video, we're going to look at the double bond. Thank you for watching. Hello everyone. In this video, we want to be